Hello everyone, welcome to the next video of Diabetes Prediction System video series. In the last video, I've discussed various requirements for the project and I've also shown you the final website that we are going to build. So in this video, we will write code for training our machine learning model. I'm using Jupyter Notebook here for writing the Python code, but you can use any other IDE. So let's begin. Okay, so I've already written the headings that are required. So we will start with importing the required libraries. First of all, we will import an important library called pandas. Now this file is used to load the data which is present in form of CSV file. So we will import it here. Import pandas as PD. Next we will import matplotlib. This library is used for plotting. Next we will import a library called seaborn. This is also a plotting library. Next we will import a function called train_test_split from sklearn.model selection import train_test_split. Then we will import a function called logistic regression from sklearn.linear_model import logistic regression. We have to use this capital R over here. And at last, we will import a function called accuracy score from sklearn.metrics import accuracy score. Okay, let's run this cell now. It's perfectly fine now. Okay, next we will move on to loading the dataset. I hope you have already downloaded the dataset, whose link I have provided in the previous as well as in this video. So here we will use the read_csv function of pandas library to load the dataset. And to store it here, we will use a variable called data equals pd.read_csv, and as an argument you have to specify the whole path of the file. In my case, the path is C, then users, then del, and then the name of the file, diabetes.csv. Now make sure you specify the correct format of the file here, otherwise it won't be opened. And we have to make it a raw string. Okay, let's print this data also. Okay, so this is the data that we have loaded. This thing I've already shown you in the previous video. It is having 8 independent columns and there is one dependent column, that is outcome. Next we will check for missing values. Now in this data set, it might be the case that some of the values are missing. So these missing values may create an error while we are training our model. So we have to check that. For that we will plot a heat map. So let's do it. It's sns.heatmap. Then our data dot is null. Okay, so this will plot a heat map. Okay, so as you can see that the map is blank. It means that there is no null values over here. That our data is perfectly fine. So we can move ahead. Okay, next we are going to find the correlation between various columns of this data. The main purpose of finding the correlation is to find that on which columns the value of the outcome is dependent. Now, for example, we have got a lot of columns in our data. As in this case, we are having just 8 columns, or you can say 8 independent columns, but there may be a situation that we have got hundreds of columns. So in that case, if we input all those 100 columns to our model, so it may not give us good results. because there would be some columns on which the value of the dependent columns is not dependent. So in order to find that which columns are relevant and which are not, we use this correlation. So we will create a variable called correlation, and in that we will store the value of various correlation between the columns that are present in this data. So we will write data dot CORR. Okay, now we will print this variable, print correlation. Okay, so it is showing us the correlation between every two column in the data. For example, you can see this, the correlation between age and glucose is 0.263514. But you can see that these correlation values are not much clear from here. So instead of just reading the correlation values like this, it's better to plot a heat map for this so that we can visualize the results. So let's create a heat map for this. Okay, it would be again sns.heatmap, and in its argument we will provide that variable correlation. Okay, so this is the heat map. Now on this right hand side, it is showing us the value of correlation as mapped to various colors. Now the darker the color, it means the value of correlation is the least. From here you can see that the correlation between age and glucose, let's say, is around 0.2. But since we have got only one dependent column over here, that is outcome, so we just need to find the correlation between the column outcome and all the other columns. It means we just have to see this column. Now from this column it can be seen that the value of this outcome variable is least dependent on blood pressure, because the correlation between outcome and blood pressure is the least. So if you want to decrease the number of variables in data, or you can say the number of columns in data, so we can drop this column blood pressure. But on the other hand, if we see the column glucose, now its value is very important while predicting the value of this column outcome, so we cannot drop this column. So in this way we can find out which columns are important and which are not. But in our case, since there are just 8 columns, so we need not to drop any column, we can just move ahead with 8 columns. So let's move on to train test split. Now for that we need to first of all create two variables that are x and y. Now the variable x will contain all the independent variables, and the variable y will contain the dependent variable, which is outcome. So let's do it. It's data dot drop, then the name of the dependent column, that is outcome, and it should drop the column row wise equals 1. Now the variable x will contain whole of the data except the column outcome, and the variable y will contain the outcome column only, so it should be data and then outcome. So let's print this variable x and see what it stores. Okay, so here you can see that there is no column outcome, and let me print y. Okay, so here you can see that there is just one column, that is outcome. So next we are going to split these columns. So next we are going to split this data. For this, first of all, we need to create four variables that are x underscore train, then x underscore test, then y underscore train, then y underscore test, and now we have to use this function train underscore test underscore split, and its first argument is x, that is all the independent variables, and second argument is y, and the third argument is the size of the test set. Now here I will specify the size of test set as 0.2, should be size equals 0.2. So this means that 20% of the whole data is present in the test set and 80% of the data is present in the train set. So let's run this once again. Okay, now if you want to see what the x underscore train variable contains, you can print it. Okay, so here you can see that there are total 614 rows, but in the whole data there were 768 rows. It means the split has occurred and it contains 80% of the data. So now once our test and train data is ready, now we are going to train the model. For that we will first create an instance of logistic regression model into a variable called model, let's say, equals logistic regression. Next we are going to train this model. So we're going to write model.fit, then x underscore train, y underscore train. It means we are giving the values and labels for the training data to this model. Okay, let's run this. Okay, there is a small warning over here, but it has run. So now we are going to make predictions out of this model. For this we are going to create a variable called predictions, let's say, and then model dot predict. Now here you have to give the argument as x underscore train. Let's run this. Okay, now let's see what this actually contains. Print predictions. Okay, it should be test here, not train, because we have already trained our model. Yes. Now these are the predictions for the test set. Now some of these predictions would be correct, but some of them would not be correct. So for that we are going to measure the accuracy of this model. For this, let's create a variable called accuracy, which equals accuracy underscore score. Now this is the function that we have already imported in the beginning. Its first argument is predictions and its second argument is the true labels, that is y underscore test. Okay, let's run this. Now we could print this accuracy. Okay, it's 75.97%. So from here we can say that if we give our data, let's suppose we give a new data to the system to predict that whether a person is having diabetes or not. So there are 75% chances that the model will predict the correct value. Now this accuracy is not really good. So there are a number of measures that you can use to increase this accuracy. Some of them are, first one is that you can use a different train to test ratio. Second one is you can normalize the data, and there are many more. And if all of them doesn't work, then one simple solution is there, that you can change the classifier. You can choose another machine learning model to predict this. Now I will not go deeper into such details to increase the accuracy, because here my motive was to show you a very simple solution on how to train a model. Now once you know how to train a basic model, then you can further use any measures to increase its accuracy. But if the basic thing is not clear, then such things are not important. So here I have shown you a very simple tip on how to train a machine learning model. So once you have trained the model on this diabetes dataset, now you are ready to train this model on any other dataset that you find useful. Now in the upcoming videos, we will build a graphical user interface for this model. We will be using Django for the same. So see you in the next video.